In this lesson, we will look at the indicating systems used to keep the crew informed of the position of the landing gear. We will then look at a typical hydraulically operated landing gear extension and retraction sequence. Although the landing gear, when selected down, may be at least partially visible from the crew compartment, it is not usually possible to be certain, by looking at it, that each landing gear is securely locked down. An electrical indicating system is used to provide a positive indication to the crew of the operation of the locks and the position of the landing gear. The system usually consists of microswitches or proximity sensors monitoring the up and down locks. These make or break electrical circuits when the locks operate, causing indications to change on the landing gear position indicator on the instrument panel. Microswitches are simple, mechanically operated electrical switches, which are operated by a striker plate when the gear reaches the required position. Most modern aircraft now use proximity switches. These are electronic devices with no moving parts. Each proximity switch consists of two components, a sensor and a target. When the sensor and target are in close proximity, a switch will be made. The picture shows the proximity sensors on a gear-down geometric lock. When the jury struts move to the over-center position, the sensor and the target move into close proximity, and a gear locked down signal is sent. The sensors are usually duplicated for safety reasons. Microswitches and proximity sensors are fully explained in the electrical systems lessons. Mechanical indicators may also be provided to show that the landing gear is down and locked if the electrical indicating system fails. For the main gear, these are often just buttons which pop up on the top of the wing when the gear is locked down. They can usually be viewed from the fuselage windows. The nose gear will often have some sort of periscopic viewer in the cockpit floor through which the downlock can be seen. Some aircraft don't have mechanical indicators. Instead, they have duplicated electrical downlock sensors. On most modern aircraft, the electrical landing gear indicating system operates in such a manner that a green light is displayed for each gear when it is locked down. A red light is displayed when the gear is not locked in the selected position, and no lights are visible when the gear is up and locked. Bulbs are usually duplicated to avoid the possibility of false indications as a result of filament failures. Many large aircraft also have main gear door lock indicators to indicate that the hydraulically operated doors are closed and locked. These lights may be red or amber. Landing gear retraction systems can be hydraulic, electrical, or pneumatic in their operation. Here we will explain the operation of a hydraulically operated system. Pneumatically and electrically operated systems function in a similar fashion. Most modern commercial aircraft have hydraulically powered landing gear systems. The hydraulic power is normally supplied by the engine-driven pumps. There will be a backup system available in case of pump or engine failure. On some light aircraft, a self-contained power pack is used. This houses a reservoir and selector valves for the landing gear and flap systems. An electrically driven pump may also be included, or the system may be powered by engine-driven pumps. The diagram here shows a typical hydraulically operated main gear in schematic form. It has a number of components that were described fully in the hydraulic systems lessons. The gear actuator and door actuator are double-acting unbalanced actuators. The gear downlock and uplock actuators are spring-applied and hydraulically released. The gear is locked down by a geometric lock mechanism. There are two sequence valves controlling the sequence of gear and door operation. The two hydraulic lines from the selector are known as the up line and the down line. The up line is pressurized when the gear is selected up, and the down line is used for return fluid. The roles are reversed when the gear is selected down. The door is hydraulically opened and closed. It is closed when the gear is locked up or down. It opens to allow the gear to raise or lower. We will now look at the sequence of gear and door operation and the associated lights indications that you can usually expect to see on a modern airliner. For simplicity, we have only shown one main gear. However, the other main gear and the nose gear operate in the same manner. The gear lever will be within easy reach of both pilots, and the gear indicator lights are usually adjacent to it. The lights indicate the status of each individual gear. For simplicity, we will only show the lights for one gear when looking at the gear sequence. With the gear lever in the down position and the gear locked down and the hydraulically operated doors closed, the green gear down light will be on and the door open light will be out. The gear red light is a disagreement light. It illuminates at any time the gear and the lever are in disagreement. So when the gear is selected up, the first thing that happens is that the gear red light illuminates. However, the gear is still locked down, so the green gear down light remains. The selector valve controlled by the gear lever will send pressure fluid to the door actuator. The door now begins to open and the door open light illuminates. When the door is fully open, its gear sequence valve will redirect the pressure fluid to the gear downlock actuator and the gear actuator. The pressure fluid passes through the one-way restrictor valve in the full flow direction. The downlock actuator will begin to retract, breaking the geometric lock. The gear is now unlocked, so its green gear down light will go out. The gear actuator can now raise the gear. When the gear is fully up, the uplock roller will engage with the uplock actuator, causing, with spring assistance, the actuator to rotate, locking the gear up. Once the gear is locked up, the red gear light will go out. The door sequence valve now directs the hydraulic fluid to the door actuator, and the door closes. Once it is fully closed, the amber door open light will go out. With the gear up and doors closed, there will be no lights on the indicator. Once the gear is up and locked, and the door is closed, the gear lever is placed to the off position, leaving the gear unpressurized for the period of the cruise, so extending the life of the landing gear components and preventing unwanted leakage of hydraulic fluid. The sequence when the gear is selected down is basically the up sequence in reverse. When the lever is selected down, the red gear light comes on to indicate a disagreement between the lever and the gear. At the same time, fluid is directed to the door actuator. The door will open and the door light will come on. When the door is fully open, the gear sequence valve will redirect the hydraulic fluid to the gear up-lock actuator and the gear actuator. The up-lock mechanism will rotate, releasing the gear. The gear actuator will now lower the gear, assisted by the weight of the gear. To control the speed of lowering, the return fluid from the gear actuator passes through a one-way restrictor valve in the restricted flow direction. You may wonder why the restrictor is in the up line and not in the down line. When the gear is going down, pressure fluid is passing through the down line and the up line is used for return. If the restrictor was in the down pressure line, as shown on the left, the suction caused during lowering by the weight of the gear on the actuator piston pulling fluid through the restriction could be sufficient to cause cavitation of the fluid in the actuator and pipeline. Cavitation is not a good thing. It is fully explained in the hydraulic systems lessons. With the restrictor in the up or return line, as shown on the right, the speed of lowering is still controlled, but there is no problem with cavitation. Also, if the gear has to be lowered under its own weight, without hydraulic pressure available, the fluid, displaced from the actuator, will still pass through the restrictor, so the speed of lowering will still be controlled. When the gear approaches the fully down position, a powerful spring in the lockdown actuator will push the geometric lock over center, locking the gear down. The red gear light goes out and the green light comes on. Once the gear is locked down, the door sequence valve directs fluid to the door actuator, and the door closes. The door light goes out. Newer aircraft with large LCD screens will normally still have independent landing gear position indicators, but they also have the ability to provide further information about the landing gear system on a screen, as in this Airbus A320 Electronic Centralized Aircraft Monitor, or ECAM presentation. When the gear is locked down, there are green, down-pointing triangles on both the undercarriage indicator and on the ECAM screen. When the gear is neither locked up nor down, the triangles on the ECAM screen are red and unlocked is displayed on the landing gear indicator. And when it is up and locked, the displays are blank. The door positions are depicted by the symbols highlighted here. They are green when the doors are locked, closed, and amber when they are not. To summarize gear indications, the most important indication is for gear down. This is almost invariably indicated by a green light or lights. Red lights are normally used to indicate that the gear is not locked in the selected position. And lights out usually indicates gear up and doors closed. You should now have an understanding of how undercarriage extension and retraction is accomplished hydraulically, including the purpose of the sequence and one-way restrictor valves.